So in this final video on the vast and complex and diverse SAR clade, we'll entitle this last flowchart on the SAR clade as SAR Clade Roman numeral 4. And here we'll conclude by looking at the Radiolarians, the R of the SAR clade. Now, the Radiolarians, the two that you need to know. There are two Radiolarians that you need to know about. There are actually three, at least from what I saw in your textbook, but we don't need to know about the third one. The notes only cover these two. And the two to remember are the following. The Radiolarians. That's the first Radiolarian to remember. The Radiolarians are characterized by a silica internal skeleton. There's that silica term again, that silica characteristic. So keep that in mind. Be able to differentiate the ones that have silica and the ones that don't, and the differences between the ones that do have the silica. How do they use the silica at least? I think that would be an important thing to remember for an exam. Characterized by silica internal skeleton. So I think there were three that had something to do with silica at least. So that's our characteristic here, skeleton. And also to remember about the Radiolarians, they actually move, this is the first time we see this, so something to probably remember, move via a pseudo, that means fake, or not real, let's say, a pseudopodia. Podia refers to a foot. And this is just going to be a microtubule structure that allows for movement as opposed to the more of a filamentous structure that's seen within the flagella as we described when we looked at flagellal structure in the prokaryotes lecture. So this is pseudopodia, and then also we have silica again in the Radiolarians. That's all you need to know about the Radiolarians here. And the last one for the Radiolarians is the Foraminifera. Make sure I spelled this right. Did I spell it right? No, I spelled it wrong. Foraminifera. I think that's right. And this is also referred to as simply the forams. I like that a lot better than the foraminifera. These are very interesting because they actually have things called tests. Tests are simply porous shells, much like the shells that you see on most, shelled organisms like crabs. These porous shells are shells that have holes within them. And this is a structure, and thus it will have an important function for these organisms. And these shells, whenever you see shells, some sort of hard structure, a converging note about this is that they are usually composed of calcium carbonate. And this is not the first time we see calcium carbonate in our Protists lecture, so keep that in mind. Things that have calcium carbonate, things that don't. So that's our characteristic here. And then finally about foraminifera, or the forams, when they die, so they have a hard outside structure, shells. When they die, they form thick marine sediments. Form thick marine, so that means they live in the oceans probably, sediments. And sediments, this is similar too. This is similar to the diatoms. The diatoms that float, that sink all the way down. The foraminifera also sink all the way down. Billions of shells converge and combine and accumulate at the bottoms of these oceans to give us these marine sediments that can be useful in terms of understanding the fossilization of certain organisms within the water. So that's it. That covers our Radiolarians. The other one that's mentioned, at least in your textbook, is the Cercozoans, but they were not covered in my notes, so I'm not going to be covering them. I'll just mention them just in case you might be looking at your textbook and wondering, oh, where are the Cercozoans? But definitely know the Radiolarians, the Foraminifera. Final thing, and this is sort of a next flowchart, but I have room on the bottom, so I'll just summarize everything about the SAR clade that we did just with names, okay? Just so that we have a clear understanding of where the SAR clade is. And actually, I'm going to start at the very top. We're going to start at domain eukarya. For the past couple of flowcharts, we've been doing domain eukarya. Within it, we've been looking at the Protists, right? And within the Protists, we already covered the Excavata supergroup. Now we're covering the SAR clade. So now we're covering the SAR clade. So let's write that down. And within the SAR clade, the past couple of videos, four flowcharts that we have covered the Stramenopiles, which is the S in SAR, Stramenopiles. The Stramenopiles consisted of the diatoms. These are just names right now, no characteristics, just to make sure we're on the same page. We covered the golden algae, And next to the golden algae would be the brown algae. Most complex protists, brown algae. Okay, so we have that clear. Stratigraphy is good. That's the S. Let's do the A. We also covered the alveolates. The alveolates themselves consisted of also three. The dinoflagellates. Okay, we also had the apicocomplexans. Reason for malaria, apicocomplexans, Plasmodium. And then we also had the ciliates. So that covers our alveolates, thus it covers the A in the SAR clade. And then finally we looked at right now, right above us, we have the Rhizairians. And the Rhizairians also have three, but we only need to know two of them, which are the Radiolarians, which are right above, and also the Foraminifera. And so we have all of the SAR clade right over here. And let's just not forget, we also covered within the protists, not just SAR, but we also covered excavata, which was the first supergroup. Remember how we did 1? This is the second supergroup, 2, and we're also going to cover the third supergroup. And that third supergroup will be our Archaeplastida. So we'll write that down as a future video. The next one actually will cover the Archaeplastida. Okay? And that covers our SAR clade. Huge clade, huge amount of diversity. Make sure you have this general idea of understanding where each thing falls. It'll be much easier to remember the characteristics upon characterizing and grouping them in the correct spaces.